these are the solutions to the linear functions test from 2018, so let's get stuck into them. Okay, so this first question here, we were simplifying these expressions. So writing that in its simplest form involves putting it over or expressing it as a fraction, which is 6x squared yz over 12xy. Now when it's expressed as a fraction, it's quite easy to see what can cancel out with what. So we've got 6 on 12 is the same as 1 on 2. X squared on x, well, one lot of the x on x's cancels out, or is 1 over 1, so we're going to cancel that and cancel that. We're going to cancel out the y's because y over y is just the same as 1 over 1, and we've got x times z in the numerator and 2 in the denominator, so xz on a 2. Alright, for question B here, it wasn't particularly well done, and a lot of students just cancelled these A and 2 and 10. But because we've got these terms being added here, these just don't cancel out, and so the best bet is to actually just run the multiplication first of all. So we're going to go 2a plus 4 all over 10a. Now what we've got here is the product of terms, and actually this 2 and 10 can cancel out just like this 6 and 12 did cancel. So we're going to go 1 and 5, and actually that's all we can do. 1 times this bracket here is just a plus 4, and 5 times a is 5a. Alright, on to question 2. So solving the following equations. So equations implies that we've got a statement of equivalence here. Alright, so what we're going to do with this one is get all of the a's onto one side and all of the constants onto the other. So we're going to add 2a to this side and add 2a to this side. That gives us 6a equals, or 6a take 5 equals 7. We're going to add 5 and add 5 to this side, and we're left with 6a equals 12. We divide both sides by 6, and we've got a equals 2. Alright, on to this one here, which is really just 1 degree harder than this one here. All we do is we actually just run the distributive law on both sides here. So we're going to go 10h plus 15 equals 12h plus 4. Now it's the same problem as here, so what we're going to do is get all of the h's on one side and all of the constants on the other. So I'm going to take 12h from this side. I'm left with negative 2h plus 15 equals 4. Now I'm going to subtract 15 and subtract 15. Negative 2h equals negative 11. H, let's not do that. Control Z, Z. We're going to divide by negative 2, divide by negative 2. H equals 11 on 2. Alright. Now to the tough one. A good slab of my class got this right, so it's good to see that. Okay, well what we'll do with this one here is we'll write these as a fraction. We'll get a common denominator, so we're going to go times 4 and times 3 and times 4. So let's rewrite this line. We've got 4 bracket 2x takes 6, take x plus 3, x plus 7, all over 12 equals negative 2. Let's expand these out first maybe. So we've got 8x take 24, take 3x take 21 equals negative 2, and this one is all over 12. Now we're going to multiply both sides by 12, and I'll collect up my like terms all in one hit. So that's negative 24, and 8x take 3x is 5x. This is take 45. Alright, now two-step equation. I'll add 45 and add 45, which is 21 and 5x. Divide by 5, divide by 5. X equals 21 on 5. Alright, it's a tough problem, that one. Okay, so over here, solve the following inequalities and graph their solutions on the number lines below. Alright, so this one here, what I'm going to do is divide by 2 and divide by 2. That leaves me with 4x plus 1 greater than 3. Now I'm going to subtract 1, 4x greater than 2, x is greater than 2 on 4, x is greater than or equal to a half. So I can mark a half there. Greater than and equal to means the point is included, and we want all the values greater than a half. Okay, over here what we're going to do is multiply by 7 and multiply by 7. Negative 3x greater than 7 sixes are 42. Divide by negative 3, divide by negative 3, whoop. Okay, when I divide or multiply by a negative number, to keep the inequality true, I need to flip that inequality. So it's going to be less than x, and 3 goes into 42, 14 times negative 14. Okay, so there is negative 14, it's less than, so we're going to hollow out that point and take all the values less than it. Alright, you guys are getting better at mapping since we started this 2 or 3 years ago. So we started with the point 2, on the line y equals x, and if you reflect it in the x-axis, that point becomes 2, neg 2. Okay, remember, a reflection in the x-axis changes the y value. Right, dilated by a factor of 2 means that that point becomes 4. We're multiplying all of the y values that we're transforming by a scale factor of 2. Alright, and vertically translated up 5 means that the y value moves up 5 units, so from negative 4 it'll go to 1. Alright, stating the equation, well, it's y equals, and because it's been reflected it's negative. The dilation factor goes there and the vertical translation goes there. And a good way of just checking I have got the equation is I can just test this point out here, if indeed this point is correct, by summing it in. So I could just roughly go 1 equals negative 2 times 2 plus 5, 1 equals negative 4 plus 5, 1 equals 1. Yay, we got it right. Okay, find the equations for the following linear relationships, a line joining these points. So again, there's just a plethora of ways of working out gradients. For this one here, I would personally use y2 take y1 over x2 take x1. So m equals, we've got negative 8 and I'm subtracting 7 off that, and I've got 4 and I'm subtracting negative 1, which is adding 1. Negative 15 over 5, m equals negative 3. So this is suggesting that my gradient is a negative gradient. Let's double check that. So what I would do is draw just a dodgy Cartesian plane off to the side here. Negative 1, 7 might be somewhere there. 4 and negative 8 somewhere down there. Okay, and I'm going to get a negative gradient. So whilst I'm not 100% confident I'm correct, I'm very confident that at least the sign of my gradient is correct. And this is something that you guys can do quite easily because many of you guys, well not many, but a few of you guys listed the answer as positive 3 when you messed up the negatives over here. So yeah, it's something that you need to be careful of. Okay, so I know now my equation takes the form y equals 3x plus c. So I put the gradient in. Now I'm just going to choose one of these points to sub in. So I'm going to choose this one. 7 equals negative 3 times negative 1 plus c. 7 equals 3 plus c. Take 3, take 3. c equals 4. So my equation is y equals negative 3x plus 4. Alright, well, the perpendicular line question. So what we've got is a line running perpendicular to this line here. So the gradient m1 of this line here is negative 2. That means the gradient of the line that runs perpendicular is going to be the negative reciprocal of this. Alright, so that negated will be a positive number, and the reciprocal of 2, which is 2 over 1, is going to be 1 over 2. Now remember, a good way of checking this is if you multiply the gradients of perpendicular lines together, the answer has to be negative 1. Right, now I know it passes through this point here, which is actually the y-intercept, and this is really convenient because this now leads us straight to our answer. Y equals half x plus 2. Our y-intercept can go straight in. Alright, exact distance between these coordinate points here. Okay, so what we're going to do is essentially use Pythagoras Theorem, and we're going to work out the difference between these 2 points here and the difference between these 2 points here. So it's going to be 12 squared and 7 squared, and we're adding them together. D equals 144 plus 49. D equals, what will that be, 184 root 193, and yeah, I'm pretty confident that that's as simple as the 193 gets. Or yeah, pretty confident. I think 193 is prime. I can't be sure of it, but I'm pretty confident. Okay, determine the values of A and B if the midpoint of this coordinate here and this coordinate here is this. Well, remember that the midpoint formula is the average of the x values. So the x coordinate of the midpoint is the average of the x values. So I know that they've given me the x value, it's -6, and our x values are a plus 5 on 2. So that's -12 equals a plus 5, and we're going to take 5, a must be -17. Alright, we're going to do the same thing for the y values. Cancel that. Y1 plus y2 all over 2. Okay, my y value is 7, and my y coordinates are 4 plus b on 2. 14 equals 4 plus b. I'm just multiplying by 2, and I did the same over here if you didn't or missed that step. And I'm going to take 4 and take 4 and take 4. B must be 10. And if you weren't pushed for time, what I would do is quickly substitute those values in there, and it should produce a midpoint of -6, 7. Alright, the sketches, using an appropriate method, okay, and we're not expected to actually find x and y intercepts, so it doesn't really state that we have to do that, so I'm allowed to choose whichever way I want to do this. So for this one here, the y-intercept is -4, so there's my first coordinate point, and I tend to use as x increases by 1, looking for the change in y values, but with fractional gradients I tend not to, so I'm going to sub in a random point. I'm just going to sub x equals 2 in. Alright, so 2 over 2 is 1, 1 take 4, y equals -3. So when x equals 2 rather, the y value is -3. There it is there, and that was good enough then to send a line through. Well, that's a pretty bad effort. I'm drawing on a little thing like a mouse pad here, so actually I'm not drawing straight on the screen, so it's hard to draw straight lines on this thing. Alright, now for restricted domain, the rule is that you must use endpoints. Okay, so I wrote that down just to get a bit more emphasis. Okay, so use those endpoints. So we've got really no choice here. We've got to sub in x equals -2 into this and find out the y value. So let's do that. -4, take y equals 4, add 4 to both sides. -y equals 8, y equals -8. So when x is -2, let's mark it in there, y is -8. Okay, and because it's a less than or equal to, it's definitely a filled point. Alright, now we're going to do the same when x is 3. We're going to use this value now and stick it into that. We've got 2 times 3, which is 6, take y plus 4, 6 take y plus 4. Now we're going to subtract 6, -2, y equals 2. So when x is 3, which is about there, y is 2, which, looking at the scale, would be around there, and again, because it's less than or equal to, then we include that point. Now we've got to link those up. Okay, you're going to use a ruler on that, but I'm not, and we're not going to go any further than those endpoints because that is the domain for which it's true for. Okay, linear function with equations. The linear function with equation y equals 3x take 4 does not pass through the point. There's no really easy way to do this one. We could quickly rule out ones that can't be true. So that can't be true because that is the y-intercept and it must pass through the y-intercept. This one we can rule out because as x increases by 1 from the y-intercept, the y value goes up by 3. So yes, so that definitely goes through that point. But I think the answer from memory was D, so what you would do is sub it in, y, or -7 equals -1 times 3 take 4, -7 equals -3 take 4, -7 equals -7. No, it does pass through that point. That's all good, so it passes through that, it passes through that. Which one was it? Looks like B, I think. 4 equals 3 times 3 take 4, 4 equals 6 take 4, 4 does not equal 2. Okay, not equal 2, so that's our winner there. All of them will have the LHS, the left hand side and the right hand side equaling each other. Okay, the gradient of the line joining these points is 4, the value of A must be. Okay, there's a couple of ways of doing this question. You can use m equals y2 take y1 over x2 take x1, and then you could substitute the values into that. So I'm actually going to do that. We've got A take 1 over 6 take 2, which is 4. Multiply both sides by 4, 16 equals A take 1, and A equals 17. So there's our answer there. The other way I could do it is 2, 1 is my first point, and let's just increase the x value by 1, the y value goes up by 4. So 3, 5, 4, 9, 5, 13, 6, 17. So the y value must be 17, using our understanding that as x increases by 1, the y value changes by 4, or goes up by 4. Okay, the equation of the linear graph with a gradient of -3 and a y-intercept of 4 is... Alright, so I think from memory the answer to this one was B. Anyway, let's just draw up what... So it's going to be y equals -3x plus 4. Alright, now that rules out that, and it rules out that. Now what we'd have to do here is get this into this form here. We notice that all of them have 2y, so what I'm going to do is multiply this equation by 2. That's 2y equals -6x plus 8. And now it looks like we've got all of the x's and y's on the left hand side and the constant on the right, which is intercept form. So we're going to go 2y plus 6x equals 8. 2y plus 6x equals 8. It was C. Alright, the equation that best represents the graph below is... Alright, so we have got this restricted domain, and we're not including the value x equals 0, and we are including 2. Okay, so this one is a possibility just by looking at the restricted domain. This one's out. This one's out because they're including them both. This one includes neither, and yeah, that means for all the values other than between 2 and 0, so, or 0 and 2, so that's out. So our answer must be A. The equation for the relationship shown below is, well, this is the line, so let's just see, let's sub in an x value, -2, what's the y value? It's -2. X equals 2, the y value is -2. X equals 4, the y value is -2. You note that the y value is always -2. What looks like to be the most likely candidate? It's this one here. the y value is always -2. Alright, this last one here will probably be the first legit case of using your calculator. Sarah and her friends bought 5 drinks and 4 bags of popcorn, spending $14. Let's go 5x plus 4y equals 14. And her friends bought 4 drinks, 4x, which is the drinks, and 3y is the popcorn, and 1080. So what I would do is jump onto main, and I'm going to go keyboard, and my old friend the simultaneous equations template. $1.20 for a drink and $2 for popcorn. D. Alright, on to the analysis. Alright, so as part of the sustainability program, Sacré-Cœur installed a 12,000 litre tank which collected rainwater from the roof of the old building to water the garden. At the end of summer there was only 1,000 litres of water in this tank. Alright, so that's sounding suspiciously like an initial value. Over a 4-day period, it rained at a steady rate and the volume of the water in the tank increased to 3/4 of its full capacity. So there's its full capacity, 12,000, I'm just going over to my calc, times 3/4, or 3/4 of its full capacity means after 4 days the volume was 9,000 litres. Sketch the graph showing the volume of water in the tank V litres against the number of days. Alright, so we've got time on the x-axis, V volume on the y-axis. At time 0, it's 1,000 litres, 2,000, 3,000, 4,000, 5,000, 6,000, 7,000. So roughly there, we're going to go 9,000. So our first point is there, 1, 2, 3, 4 days, 9,000 up there. Endpoints are both included and a straight line joins these, and it's only between 0 and 4. Alright, what does the y-intercept represent in the context of this situation? So the y-intercept is when x is 0, y is 1,000, and we want to say something like there was initially 1,000 litres of water in the tank. So the key word is start or initial or something like that. Okay, determine the gradient and explain what it represents. So the gradient is the change in y values, which is 9,000 take away 1,000, so it's 8,000, over the change in x values for the same period, or d values, which is 4. Now that will be 2,000. Okay, so I would say something like as, or no, not as, for every increase of 1 day, the capacity of the tank increased by 2,000 litres. State the equation for the volume of water V litres in this tank while it's raining. So it'll be V equals the gradient, 2,000 D, and the y-intercept plus 1,000. Alright, on to the last question. On the day the rain started, D equals 0, Jared used water from a second water tank to fill a new 7,000 litre pond in the Kirby courtyard. Initially there was 11,000 litres of water in this tank, that is in the second tank. Water was pumped into an empty pond at a steady rate of 2,000 litres per day. How long did it take to completely fill the pond? Alright, so the pond has a capacity of 7,000 litres, so we're going to go 7,000 divided by how many litres go in per day, and that is going to be 7 over 2, which is 3.5, so 3 and a half days, 3.5 days, whichever one you wanted. What is the volume? What volume of water was left in the second tank after the pool was filled? All right. Well, if there was 11,000 litres in the tank and it filled this to capacity, the difference is 4,000. Okay, so I do 11,000. Take away the water I pumped out, and it gives me 4,000 litres. Find the equation for the line that describes the change in the volume of the water V litres in the second tank for the time in D days it takes to fill the pond. Okay, so what we're going to do is V equals. Okay, now we need to work out the gradient. Now, what's happening is water is pumped into an empty pond, so it's actually pumping stuff out of the second tank. Okay, which means that this gradient must be negative. Negative 2,000 D plus its initial capacity, which is 11,000. At one point there was the same amount of water in the pond as there was in the second tank. Determine how long. So at one point there was the same amount of water in the pond as there was in the second tank. Determine how long it took for this to occur and state the volume of water in the pond and the old tank at that time. Alright, so the pond is filling up, and the volume of the pond is going to be 2,000 D plus 0. Okay, that's the volume of the tank at the pond. So we're talking about the pond here. So the pond, remember, was initially empty, so it has no water in it, and the rate of change is 2,000 litres for every increase of 1 day. Alright, and now what we're going to look at is the equation for the second tank, which was B equals negative 2,000 D plus 11,000. Now if we understand what's happening here, this will be the equation of the pond. Okay, it's increasing at a rate of 2,000. This one will be the second tank, and the intersection point of these will give us the value when it's the same. So again, I would use my old friend the simultaneous equations template and go y equals 2,000x. Again, I use x's and y's rather than v's and d's because the x's and y's are well accessible here. Y equals negative 2,000 x plus 11,000 xy. And that occurred at after 2.75 days, okay, or 2 days 18 hours, 3/4 of 24, and state the volume of water in the pond and the old tank, so that was 5,500 litres. Now there was some confusion over this one, and if you used the old tank formula, which was the original one, you would have got 5,000 litres, but no one did that in my class. In fact, everyone came up with this answer who got this answer correct. So there's the solutions to that. I hope you find them useful and follow up with your teacher. Anything that you don't understand or anything that you would like to talk to us about.